The world as we know it runs on a pulse so vast, so deeply woven into our lives, that we scarcely notice its rhythm. Oil. It's the lifeblood of our cities, our factories, our dreams of progress. It fuels the morning commute, lights the homes we return to, and powers the machines that churn out everything from the clothes we wear to the food on our tables. A $4.3 trillion empire, it employs millions, shapes nations, and dictates the fortunes of entire economies. But what if I told you that right now, in a quiet lab in Boston, a machine no larger than a shipping container is being built that could bring this colossal industry to its knees? Not with a bang, but with a whisper, a hum of clean, limitless energy that could rewrite the rules of our world. This is no ordinary invention. This is MIT's ARC fusion reactor, a creation that could unravel the very foundation of the oil and gas industry. And the most chilling part? Almost no one is paying attention. Imagine standing at the edge of a cliff, looking out over a landscape that's about to change forever. That's where we are today. The ARC reactor isn't just another clean energy project, like solar panels glinting in the desert or wind turbines spinning on a hill. Those are important, but they flicker with limitations. Clouds block the sun, winds die down. Fusion, though, is something else entirely. It's the dream of harnessing the sun's power here on Earth, a dream that's been whispered about for decades but always seemed just out of reach. Until now. In the labs of MIT and through the bold vision of Commonwealth Fusion Systems, a spin-out born from those hallowed halls, this dream is taking shape. The ARC reactor, slated to spark into life in the early 2030s, promises to deliver 400 megawatts of clean, relentless energy, enough to power 150,000 homes from a machine small enough to fit in a modest warehouse. This isn't science fiction. The blueprints are drawn, the magnets are built, the money is flowing. And the oil giants? They're starting to sweat. Picture the oil industry as a towering ancient fortress, its walls forged from decades of wealth, power, and influence. It's a fortress that has weathered wars, economic crashes, and revolutions. But now, a new force is gathering at its gates, not with swords or cannons, but with the quiet precision of science. The ARC reactor's threat lies in its simplicity, its elegance. Unlike the sprawling refineries and pipelines that crisscross continents, this compact machine could be mass-produced, shipped anywhere, and plugged into the grid like a battery. It doesn't rely on finite reserves buried deep in the earth. Its fuel? Hydrogen isotopes pulled from seawater, the most abundant resource on our planet. No drilling, no fracking, no geopolitical chess games over oil fields. Just clean, endless energy. The implications are staggering. A 1% drop in oil demand could cost the industry tens of billions. The ARC reactor isn't aiming for 1%. It's aiming to remake the entire game. This story begins in the labs of MIT, where minds sharper than the edge of a blade are piecing together a future most of us can't yet imagine. Commonwealth Fusion Systems, led by Dennis White, a professor with a vision that could make oil executives lose sleep, isn't content with building a single reactor. Their plan is audacious. Thousands of these fusion plants, dotting the globe, each one a beacon of clean energy. They're not just dreaming of a prototype. They're already testing SPARC, a smaller scale reactor that's the stepping stone to ARC. The high-field superconducting magnets, miracles of engineering made from rare earth materials, are the heart of this machine, capable of containing the blistering heat of a star. These aren't theories scribbled on a chalkboard. They've been built, tested, and proven. Investors are pouring in billions, sensing that this isn't just a breakthrough, it's a revolution. But revolutions don't happen in a vacuum. The oil industry, vast and cunning, isn't blind to this threat. Behind closed doors, In the gleaming boardrooms of companies like Shell, BP, and Saudi Aramco, whispers of fusion are growing louder. These titans didn't build trillion-dollar empires by ignoring danger. Industry insiders reveal that investment firms like BlackRock are already modeling fusion as an existential risk to oil, running scenarios that map out a world where fossil fuels are no longer king. Shell and BP have quietly begun funding hydrogen and fusion research, hedging their bets on a future they publicly claim is decades away. 10 years ago, fusion was a punchline, the energy source that's always 30 years away. Today, it's a shadow looming over corporate strategies, a specter that even the most powerful players can't ignore. The stakes couldn't be higher. This isn't just about swapping one energy source for another. It's about a seismic shift in how the world works. Imagine a nation no longer tethered to oil tankers or gas pipelines, no longer beholden to distant regimes for its energy. Imagine a city powered by a single, compact reactor, its air cleaner, its economy freer. Now imagine that city multiplied across the globe. The nations racing to master fusion, Japan, South Korea, the United States, are already positioning themselves for this new world. Japan's fusion roadmap is a blueprint for commercial deployment, while South Korea is pouring billions into superconductor manufacturing. Meanwhile, countries like Nigeria, Venezuela, or Saudi Arabia, whose economies lean heavily on oil exports, face a future that could unravel like a threadbare tapestry. When oil's grip loosens, what happens to the wealth, the power, the very identity of these nations? This is the edge of the cliff, the moment before the plunge. The ARC reactor isn't just a machine, it's a catalyst for a new kind of world. It's about energy sovereignty, where nations no longer bow to the whims of oil markets. It's about real estate near old coal plants, where land values are creeping up as investors bet on fusion's arrival. It's about the supply chain for rare earth elements, where countries like China and Brazil hold the keys to fusion's future, potentially sidelining OPEC's long reign. This isn't just a story of science, it's a story of power, of who will rise and who will fall in the shadow of this quiet machine. As the world begins to take notice, one question lingers like a heartbeat. What happens when the fuel for our future comes not from the ground, but from the sea? The world is shifting beneath our feet, and the ground is trembling in ways we can't yet fully grasp. The ARC fusion reactor, born in the crucible of MIT's labs, isn't just a machine. It's a key to a door we've never dared to open. A door to a world where energy isn't a scarce resource fought over by nations, but a boundless force that could redefine what it means to be human. The oil industry, that towering colossus that has shaped the modern age, feels the tremor too. Its executives may not admit it in public, but in the shadowed corners of their boardrooms, they're preparing for a storm. The ARC reactor, with its promise of clean, limitless power, isn't just a competitor. It's a harbinger of a new era, one that could render their empire obsolete. As the race to fusion accelerates, the stakes are no longer just about energy. They're about power, wealth, and the very structure of our global society. Imagine a world where energy is no longer a choke point, a leverage tool wielded by a few to control the many. For over a century, oil has been the great arbiter of global affairs. It has fueled wars, toppled governments, and built empires. Its pipelines snake across continents, its tankers carve paths through stormy seas, and its reserves are guarded like treasures of ancient kings. But the ARC reactor threatens to rewrite this story. Its fuel, derived from seawater, is as universal as the air we breathe. No nation can monopolize it, no cartel can choke its supply. This is what makes fusion so dangerous to the old order. It's not just about clean energy, it's about democratizing power itself. A single ARC reactor, compact and modular, could be dropped into a rural village or a sprawling metropolis, delivering hundreds of megawatts without a single drop of oil. This isn't just a technological leap, it's a geopolitical earthquake. The oil giants see the writing on the wall, even if they don't say it aloud. Companies like Shell and BP, whose logos are as familiar as the sunrise, are quietly hedging their bets. They're funneling money into fusion and hydrogen research, not out of altruism, but survival. They know that the ARC reactor and the global race it has sparked is no longer a distant dream. Japan is mapping out commercial fusion deployment with the precision of a master strategist. South Korea is investing billions in the superconductors that will power these machines. Even China, with its vast reserves of rare earth elements, is positioning itself as a linchpin in the fusion supply chain. Meanwhile, the nations that have long leaned on oil, Saudi Arabia, Russia, Venezuela, face a future that could slip through their fingers like sand. Their economies, built on the black gold beneath their soil, could crumble if fusion scales as promised. The question isn't just whether fusion will work, it's what happens when it does. This new world is already taking shape in unexpected places. Near the rusting skeletons of decommissioned coal plants, land prices are climbing. Why? Because these sites, with their existing grid connections, are prime real estate for fusion reactors. Investors, those quiet architects of the future, are moving early, snapping up parcels before the world catches on. It's a modern gold rush, but instead of pickaxes and pans, it's about securing the infrastructure for a fusion-powered tomorrow. The supply chain is shifting too. The rare earth elements and superconductors that make the ARC's magnets possible are becoming the new oil, and nations like China and Brazil hold the keys. OPEC's grip on energy markets, once ironclad, could become a relic, replaced by a new power dynamic where control over these materials dictates influence. The ARC reactor isn't just a machine, it's a pivot point, tilting the balance of global power toward those who master its secrets. But the true magic of the ARC lies in its design, a marvel of human ingenuity that could change everything. Unlike the hulking nuclear plants of the past, which took decades to build and billions to fund, the ARC is lean, modular, almost elegant in its simplicity. Picture a factory churning out these reactors like cars off an assembly line, each one ready to be shipped to a desert, a tundra, or an island nation. No need for sprawling pipelines or deep water ports. No reliance on volatile regions or finite reserves. Just a compact unit, connected to the grid, humming with the power of a star. This modularity is what makes the ARC so revolutionary. It's not just about generating energy, it's about making energy accessible, affordable, and independent. Nations that have spent centuries begging for scraps of oil could become energy superpowers overnight, their grids lit by reactors that need only seawater to run. This vision of energy sovereignty is already stirring diplomatic circles. Governments are beginning to see fusion sites as more than power plants. They're potential national security assets, as critical as military bases or nuclear arsenals. Imagine a world where a small nation, once crippled by energy dependence, can generate more power than it needs, exporting the surplus to its neighbors. The old leverage of oil embargoes, price spikes, and pipeline politics would vanish. The strategic petroleum reserves that nations hoard like gold, obsolete. The tankers that clog our oceans, the pipelines that scar our landscapes, unnecessary. The ARC reactor, with its promise of clean, reliable power, could upend the very concept of energy scarcity that has defined global relations for generations. It's a world where every nation could, in theory, stand on its own. Yet, this transformation isn't without its shadows. The rise of fusion could create a new divide, splitting the world into fusion-ready nations and those left clinging to fossil fuels. Countries with the scientific expertise, manufacturing capacity, and vision to adopt fusion, think Japan, the US, or South Korea, are already laying the groundwork. Their universities are training the next generation of fusion engineers, their industries are retooling for superconductor production, and their governments are crafting policies to integrate this technology. But what of the nations without these resources? For places like Nigeria or Venezuela, where oil is not just an industry, but a lifeline, the rise of fusion could spell economic freefall. Entire regions could face collapse as their primary revenue source dries up. This isn't just about cleaner air, it's about who controls the future and who gets left behind. As the ARC reactor inches closer to reality, its implications ripple beyond energy. The global financial system, built on the petrodollar, could face its own reckoning. For decades, oil priced in US dollars has propped up American economic dominance, creating demand for the currency that underpins global trade. But what happens when oil's throne is toppled? MIT researchers are already exploring a radical idea: a financial system backed not by oil, but by energy itself. They're experimenting with cryptographic energy tokenization, a way to track and trade energy production with the precision of a blockchain. It's a concept that sounds like science fiction, kilowatt coins replacing petrodollars, but it's rooted in the same relentless innovation driving the ARC. If fusion redefines energy, it could also redefine wealth, power, and the very currencies that shape our world. We stand on the cusp of something monumental, a moment where the future feels both exhilarating and unnerving, like the first breath of air after diving deep underwater. The ARC fusion reactor, humming in the imagination of MIT's brightest minds, is more than a machine. It's a spark that could ignite a new chapter of human history. This isn't just about powering homes or charging cars. It's about rewriting the rules of civilization itself. The oil industry, that titan that has shaped our world for over a century, is facing a reckoning. Its pipelines, refineries, and vast networks of wealth and influence could become relics, rusting under the weight of a technology that doesn't just compete, but redefines what energy means. As the ARC reactor moves from blueprint to reality, it's pulling us toward a horizon where energy is no longer a battleground, but a birthright, abundant and clean. Yet, with this promise comes a question that lingers like a shadow. What will we lose in the world we leave behind, and what will we gain in the one we're building? The heart of this transformation lies in the ARC's ability to deliver something no other energy source has ever achieved: relentless, clean, round-the-clock power. Solar panels falter when the sun sets. Wind turbines stall when the air grows still. But fusion knows no such limits. It's the sun brought to Earth, a steady pulse of energy that could light up cities, power factories, and fuel dreams we haven't yet dared to dream. This is what makes the ARC so threatening to the oil and gas empire. It doesn't just offer an alternative. It obliterates the excuses that have kept fossil fuels alive. Airlines that lean on carbon offsets to justify their emissions, they'll have synthetic fuels powered by fusion. Steel plants that claim fossil fuels are the only way to reach scorching temperatures. Fusion can deliver heat without a whiff of carbon. The intricate dance of carbon credits, net zero pledges, and greenwashing that corporations have mastered will collapse when clean energy becomes cheaper than oil. And it will, because fusion, unlike oil, isn't bound by the limits of geology or scarcity. But the ARC's true power isn't just in its physics, it's in its convergence with another force reshaping our world: artificial intelligence. MIT isn't just building reactors. They're weaving together fusion with AI, machine learning, and quantum computing to create something extraordinary: a self-improving energy system. Imagine a reactor that learns, adapts, and optimizes itself with every second it runs, like a mind growing sharper with experience. AI-driven plasma stabilization keeps the fusion reaction steady, reacting in microseconds to conditions hotter than the sun's core. Quantum modeling refines fuel cycles with precision that borders on magic. These reactors wouldn't just sit static, like the power plants of old. They'd evolve, sharing data across a global network, each one making the others better. The cost of energy could plummet faster than we've ever seen. outpacing even the dizzying drop in computing costs over the past decades. Oil, tethered to the slow grind of extraction and refining, can't compete with a system that rewrites its own rules. This fusion AI hybrid could usher in what some are calling an energy singularity, a point where energy becomes so cheap, so abundant, that it transforms everything. Water desalination, once a costly dream, could turn deserts into farmlands. Transportation could shift to electric or hydrogen-powered systems, with fusion providing the backbone. Manufacturing, agriculture, even space exploration, activities once constrained by energy costs, could explode with possibility. As theoretical physicist Dr. Michio Kaku has said, fusion won't just give us power, it will give us Civilization 2.0. This isn't hyperbole. It's a glimpse of a world where energy is no longer a barrier but a catalyst, unlocking human potential in ways we can barely imagine. Yet, this bright future casts a long shadow over the present, where trillions of dollars in oil infrastructure, pipelines, rigs, refineries, could become stranded assets, abandoned before their time. The engineering behind the ARC is as awe-inspiring as its implications. At its core are high-field superconducting magnets, crafted from rare earth barium copper oxide, capable of generating magnetic fields twice as strong as those in older fusion designs. This isn't just a technical detail, it's the key that unlocks a smaller, more efficient reactor, one that can fit in a warehouse, yet power a small city. The ARC's modular design is a stroke of genius, allowing it to be built in factories and shipped like a product, not a mega project. Some designs even propose floating reactors, built in shipyards and anchored offshore, using the ocean as a natural coolant. These platforms could be deployed faster and cheaper than traditional nuclear plants, sidestepping the safety concerns that have long haunted the industry. The seawater advantage, the standardized construction, the relentless focus on scalability. It's as if MIT has taken the oil industry's playbook and turned it against itself, redirecting engineering prowess toward a cleaner, freer future. But this future isn't just about technology, it's about the human cost of change. The oil industry isn't just a collection of companies, it's a way of life for millions. From rig workers in Texas to engineers in Riyadh, entire communities depend on the wealth oil generates. As fusion rises, these livelihoods could vanish, leaving towns and nations scrambling to adapt. The transition won't be gentle. Countries like Saudi Arabia or Nigeria, whose economies are tethered to oil, could face turmoil as their revenue streams dry up. Even in wealthier nations, the shift could disrupt markets, with billions in green finance, carbon credits, ESG funds, rendered obsolete when decarbonization becomes not a struggle but a default. The petrodollar, the financial bedrock of global trade, could give way to a new system where energy production, not oil reserves, dictates economic power. MIT's experiments with energy tokenization hint at a world where kilowatts, not barrels, define wealth. This is the great energy reset, a moment that could redefine who holds power in the 21st century. The nations that lead in fusion, those with the science, the supply chains, the vision, will shape the rules of this new world. Japan, South Korea, the US, and others are racing to set the standard, to become the architects of a fusion-powered future. But for every winner, there's a loser. The oil giants, once unassailable, face a choice: pivot to new energy, or fade like the whaling fleets of the 19th century. History is unkind to those who cling to the old ways. The companies that ruled mainframes didn't lead in personal computing. The titans of landlines faltered in the wireless age. The oil majors, for all their wealth and influence, may not survive the fusion era intact. As we peer into this future, we're left with a question that echoes through the ages. What does it mean to wield power responsibly? Fusion offers a world of abundance, but it also demands we confront the inequalities it could create. The nations and people left behind in this transition, those tied to fossil fuels, will need a bridge to this new era, not a cliff. The ARC reactor, for all its promise, isn't a savior on its own. It's a tool, one that could light up the world or deepen its divide, Sajays. The choice is ours. Will we use this power to lift up those who've been left in the dark? Or will we let the old empires fall without a plan for what comes next? The hum of the ARC reactor is growing louder, and with it, the world is changing. This is no longer about if, but when, and who will shape the story that comes after.